All right, hey guys, this video is going to go over how to simplify radicals. So just a couple quick vocab before we get started. A radical symbol is actually like the square root symbol here, or a cube root symbol. That's a radical. A fourth root symbol. Those are actually called the radicals. The number on the inside, that also has a special name. That's called a radicand. Okay, or radicand, however you want to say it. So today we're going to learn how we can simplify a radical, and we just call that kind of the whole thing, a name for it is a radical. So we're going to try to simplify like the square root of 50. So in order to simplify radicals, we need to have a list of the perfect squares, because this is going to help us simplify radicals. So perfect squares, remember, are the numbers you can take a nice square root of, like 25. That's a perfect square because 5 times 5 is 25. Think about it like a square. That would be a 5 by 5 square. The area is 25. Those are perfect squares. So let's make a list of the first, 12 or 13 perfect squares. So I'm going to start with 1. 1 times 1 is 1 if I had a 1 by 1 square. 2 times 2 is 4. That would be if I had a 2 by 2 square. The area would be 4. 3 by 3 is 9. 4 by 4 is 16. 5 by 5 is 25. 6 by 6 is 36. 7 by 7 is 49. 8 by 8 is 64. 9 by 9 is 81. 10 squared is 100, 11 is 121, 12 is 144, and that's probably enough for now. So please make sure you have these written down in your notes, because you are definitely going to be using them today. Okay, so today we are going to learn how to change, how to tell if something is in simple radical form and how to change it if it's not. So here's how you can tell if something is in simple radical form. If when you look inside in the radicand, or the number inside, like this number 33, it has no square factors and it's not a fraction. So I'm going to look at this, 33. If I look at my list of perfect squares, none of those go into 33. This is as simple as it can be. This is in simple radical form. You cannot break that down anymore. Now, the square root of 12. There is a perfect square that goes into 12. If I kind of look at my list, I already see 4 will go into 12. So this is not in perfect form. We're going to figure out how you do write it in perfect form. Square root of 6, if you look at your list, there's nothing that goes into it. So this is in simple radical form. Square root of 1/4, it's a fraction. It is not in simple radical form. Square root of 48, well, I already can see 4 goes in there. 16 also goes in there. So this is not in simple radical form. And 99, I know 9 goes in there. That's a perfect square. So that is not in simple radical form. So we are going to learn how to change these ones that I crossed off into simple radical form. Okay, so I'm going to show you 2 different methods that you can use to solve this, and you can choose whatever method you like. So the first method is called rewriting it or extracting the root. So here's what it means. Basically, you can take the square root of 50. And what I like to, and this is the method I like, I look at this is called a radicand inside here, and see if I can break it down into some perfect squares. So it's really helpful to have this list here, okay? I always look at this list and I see, okay, what's the biggest perfect square that goes into 50? Well, I think 25 goes into 50. So I am going to rewrite 50. 50 is the same as saying 25 times 2, okay? I did not change this problem. I just rewrote it a different way. 25 times 2, that's still 50. Now, when you have something like this, you can actually break it down into a problem like this. The square root of 25 times the square root of 2. You can actually break it up like that. So now, if I solve that, the square root of 25 is 5, and then I still have times the square root of 2. So my final answer is 5 times the square root of 2. This is one method to rewrite it in the simplest form. Now, to make sure that you are done, you always want to check inside here and see, okay, 2. Is there any other perfect square from this list that goes into 2? Nope, so I can't break it down any further than that. Again, if you want to check to see if this is right, you can actually on your calculator type in the square root of 50, see what you get, and then on your calculator, I would type in the square root of 2, see what you get, times it by 5. These two should be equal to each other, and they are. Okay, so let me show you again how I do that. So square root of 80. So first thing I always do is I try to rewrite it, and I look at my list of perfect squares up here, and I try to find one that goes into 80. Now you can use your calculator. Obviously, it's going to be below 81. 64 does not go in there. 49 doesn't. 36 doesn't go into 80. 25 doesn't, but I think 16 does. If you're not sure, you can just type in 80 divided by 16 and see. It goes in there 5 times. So 80, the square root of 80 is the same as saying the square root of 16 times 5. Now, again, you can rewrite it like this. That's the same as saying the square root of 16 times the square root of 5. Okay, so the square root of 16 is actually 4. And then I still need to times that by the square root of 5. So my final simplified answer is 4 square root 5. Okay, this is a simpler way than writing the square root of 80. Now, these are equal to each other. If you typed it in on your calculator, they would equal the exact same thing. This is just simplest form. All right, square root of 300. Now, if I was going to do that one, here's what I would do. Square root of 300 right away. I know 100 goes in there. That's an easy one. So I'm going to break it up in 3 times 100. Now, I typically don't rewrite it like I did up here. I just think, well, the square root of 100 is 10, and then I still have times that square root of 3. So my final answer is 10 square root 3. Now, again, you always want to double check your radicand, the number on the inside. Is that all the way simplified? Is there any square factor that goes into 3? Well, 1 does, but you can't really break down 1 any further. So there's no other number that goes into it. Okay, square root of 98. Okay, this is probably one you wouldn't know off the top of your head. So I just kind of started typing in 98 divided by 1, 98 divided by 4. And right away, 98 divided by 9, not working. I end up with 49 does end up going into it. So it's actually 49 times 2. Okay, now again, you can break it up into the square root of 49 times the square root of 2. Square root of 49 is 7, so I end up with 7 times the square root of 2. This is the simpler way to write that. All right, I also want to show you what happens if you don't choose the highest number right away. So if you guys take a look at this one, square root of 80, here's how we broke it up. We did 16 times 5, square root of 16 was 4, and then I still had 10 to the square root of 5. Let's say that you didn't get that 16 was the biggest square factor that went into 80. Let's say you thought, oh, well, 4 goes in there, and it was 4 times 20. Okay, and then I knew the square root of 4 is 2, so I have 2 times the square root of 20. Now, hopefully if you got this far, you would notice, oh, 20, I think there's probably some numbers that might go into 20, some square numbers, some perfect squares. And actually, so you have to do a little bit more work. I'm going to do 2 square root of 20. I know 4 also goes into 20, so I have 4 times 5. So now here's what I think to myself. I have 2 times the square root of 4 times the square root of 5. Okay, well, that's the same as 2 times the square root of 4 is actually 2, and then times the square root of 5. And then to break this down a little bit more, 2 times 2, that's the same as 4 times the square root of 5. So either way I did it, I get the same answer. If you don't find the biggest square factor that goes into the number, like here it was 16, if you don't find that biggest one, you're just going to have more steps. All right, a second method that you can use is something called the factor tree method. Now, when you were first learning how to multiply, you guys made factor trees. So I'm going to show you how this works with 50. So what you can do is you can start making a factor tree for 50. So I know 10 times 5 is 50. Okay, I'm going to break it down some more. 5 is a prime number, so I'm done right there. 10, 2 times 5 is 10. So I have 2 and 5. Okay, so now I'm going to actually rewrite the square root of 50 as 2 times 5 times 5. Now that also equals 50. Okay, if I multiply that out, that does equal 50. Now, here, 5 times 5, that's the same as 25, right? If you have 2 of the same factors, 5 times 5 is 25. So this is the same as saying 2 times 25, or the square root of 2 times the square root of 25. Square root of 25 is 5, and then I still have times the square root of 2. So there's your final answer for that. All right, let me show you another one. Square root of 128. So I don't know too many numbers that go into 128, so I'm just going to start with 2. I end up with 2 times 64. Okay, 2 is a prime number. I usually circle that. 64. I know 8 times 8 is 64. I can break 8 down even more. 4 times 2. Okay, 2 is a prime number. 4 is 2 times 2. Those are prime numbers. 8 over here is 4 times 2. Prime number. 4 is 2 times 2. Prime number. So 128 is the same as actually saying I count 1, 2, 3, 4, 5, 6, 7 2s. 2 times 2 times 2. 7 of these. 5, 6, 7. Okay, so now I usually like to just think if I group those in twos, 2 times 2 is 4, square root of that is 2. 2 times 2 is 2, the square root of that is going to give me 2. 2 times 2 is 4, square root of that is going to give me 2. And then I'm still left with this 1 square root of 2. Okay, so here's my answer so far. Now I just need to multiply. 2 times 2 is 4, times 2 is 8. So my final answer is 8 times the square root of 2. Okay, let's show you one more of those again in case you like this method. So 140, I can just start with anything that goes into 140. I'm going to go 14 times 10. You do not have to pick the same numbers as me. So 14, I can break that down into 7 times 2. 7 is prime, so is 2. 10, that's 2 times 5. Okay, so now this is the same as writing the square root of 2 times 2 times 5 times 7. Okay, now when there's two factors of the same thing, if you multiply it, 2 times 2 is 4. And then when I square root that, I get 2. And then I still have 5 times 7. So that's going to end up being 2 times the square root of 5 times 7 is 35. I cannot break that down anymore. There's no perfect square factor that goes into there. So there's my final answer. All right, last type of problem. You might see some that looks like this. Okay, so if you have one that already has a 3 on the outside, that is just saying 3 times the square root of 600. Okay, now I'm going to do it this way for this problem. I'm going to break 600 down. I know that's the same as saying 100 times 6. Okay, so I can rewrite that again as 3 times the square root of 100 times the square root of 6 if I want to break this down even more. The square root of 100 is 10, so I get 3 times 10 times the square root of 6. Now I just have 3 times 10, which is 30, times the square root of 6. And then just double check that radicand on the inside. Is there any perfect square factor that goes into 6? There is not, so then this is as far as I can simplify it down. Okay, I'd like you to pick one of the two methods and try to simplify the square root of 392. Push play when you're ready to see the answers. All right, so your final answer should be 14 times the square root of 2. No matter what way you did it, you should end up with that for your final answer. If you have any questions, please ask your teacher.